Welcome, scholars, to Mr. Honeycutt's math class. This portion of the lesson, we're determining factored form from a graph. We're eventually going to put this all together with sign charts using in behaviors and such as we did before, but right now we're just determining factored form from a graph. So, graph to factored form, remember, just as a reminder, remember when the graph crosses or touches the x-axis, the polynomial, the function has a 0 there. Where the polynomial has a 0, the polynomial crosses or touches the x-axis. These two are equivalent conceptually, and we can, because of that, we can work backward from the graph to the zeros. So for instance, using the graph to find the factors. Hey, look at this. So looking at the graph, hey, where's the 0? Well, there's a 0 here, there's a 0 here, and there's a 0 here. So that means, what are my zeros? Well, the first one is x equals -2. All right. The next one is x equals 0. And the third one is x equals +1. What I'm then going to do to find factors is I'm going to sort of solve for 0. Okay. So I'm going to take that -2, that x equals -2, and I'm going to add 2 to both sides. All right, so that I get this term x plus 2 equals 0. And then there is my factor, that x plus 2. And then for x equals 0, hey, I'm already there actually. At x equals 0. Awesome. But I got to remember that there's a term here for the x. Anytime it goes to the origin, there's an x factor by itself. At the x equals +1 term, I'm going to subtract 1 from both sides. And then I get this x minus 1 term. And then here's the factor. And then I can just multiply these together. So that one goes here, the x goes here, and the x minus 1 goes here. I have put this little reminder that now those are the zeros. You could multiply this by any sort of multiple to then figure out what the actual size of the function is. And often IB will have you do that, which is why I wanted to include it there. So remember, there's still a multiple out there, but notice we've gotten most of the function. All we need is one other point, you know, like here or something, to then figure out what the exact actual multiple of all these is. And all I would then do, by the way, to find that is I would plug in the value here for my x's, set that equal to whatever the output is, and from there I would solve for a. Okay. Notice we also do need to check the signs, okay? So notice this function has the exact same zeros, 1 at 2, 1 at 0, and at 1, but opposite in behaviors. Hey, in behaviors are important. So that's where on the right in behavior, it's going to -infinity, and the left in behavior is going to +infinity. That means it's got to have a negative out front. Okay, there must be a negative sign attached. So watch out. Those in behaviors are important. Check to make sure that this actually would be making sense. And there is, again, still this multiple that we're not really sure about. Might have to find it some other way. Let's do another one. Okay, checking don't forget to check multiplicity of zeros here. So we've got 1 here, got another 0 here, and hey, we also have a bounce here, which means it's a double 0. Okay, so I've got like x equals -2. I've got x equals 1. I've got x equals 4. I'm going to turn these all into zeros. So add 2, x plus 2 equals 0. Minus 1, minus 1. X minus 1 equals 0. Minus 4. 4. X minus 4 equals 0. However, as I'm making my function, all right, I've got that multiple. Notice my in behaviors are positive, so I don't have to worry about the positive. All right, then I'll have this factor, x plus 2. All right, I'm going to have, let's start with this last factor, x minus 4. What's special about this one is it's a double. It goes against the x-axis and it bounces against us, which means that this x minus 1 factor is actually squared. Okay, that's why it bounces. And if we didn't put this here, we would get the wrong graph. Okay, because we need to know. And also for our purposes, especially as we're about to do sign charts, is notice that the sign doesn't change here. Okay, it's positive here, it's negative here, and positive here. The fact that there's a 0 here but no sign change is also another hint that this is a double 0. Or a bounce, graphically, if you want to call it that. Let's see if we can find factored form on this one. So we've got a 0 here. All right, a 0 here. Some other sort of 0 here. Notice this one doesn't have a direct cross. So I got x equals 1, x equals 3, x equals 5. So this is going to be the term x minus 1, the term x minus 3, and the term x minus 5. Notice there's something weird going on here. It's not a direct. It doesn't immediately cross. This one is a bounce, though. Okay, so this term is going to be a double. This guy, because of the weirdness, okay, notice that weirdness kind of looks like an x cubed. That's because it's a triple. So in putting this function together, all right, I have the constant multiple that I'm not entirely sure of what it is. All right, I got x minus 1 squared, x minus 3. This is just a simple cross, right? And then I've got the x minus 5, which is cubed, and I can tell from this one. What's nice about this, if you get a little confused here, like this is obviously a triple, but if you miss that and you just notice, hey, it crosses, for purposes of sign charts, this is going to go from negative to positive because it's the same thing. It's going to be the same sign-wise as this. The sign changes on these triples. All right, moving along. For rational functions, let's label some features and find some factors. Okay, let's start with some of the easy stuff. Let's start with some zeros. I got a 0 here at -4 and a 0 at 2. And then I've got some asymptotes and some asymptotes here. Okay, my zeros are going to go in the numerator. My asymptotes are going to go in the denominator. And then I've got what's called a whole. I've talked about this before, but so in here, that means it's going to go, remember wholes mean it's going to go both in the numerator and the denominator. So let's figure out our terms here. So for my zeros, my x-intercepts, if you will, okay, I've got x equals -4, and I've got x equals 2. So that's going to give me the factors, x plus 4, and the factor x minus 2 when I solve. For my asymptotes, my vertical asymptotes, I've got x equals -2, and I've got x equals 5. Solving those as terms, it's going to be x plus 2 and x minus 5. And for the whole, I've got, what is that, x equals 8, so it's going to be the term x minus 8. So then putting that all together in an f of x, I've got some multiple in the numerators, x plus 4, and then x minus 2. And then I've got, for the denominators, which create the vertical asymptotes, x plus 2 and x minus 5. And then for the whole, I've got x minus 8 in both of these. So again, remember, my x-intercepts go in the numerator. My vertical asymptotes go in the denominator, because dividing by 0, multiplying by 0, okay, creates an x-intercept. Dividing by 0 creates a vertical asymptote. When you're doing both at the same time, that creates a whole. Now let's see if we can find factored form on this one. So I've got an x-intercept, 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 x-intercept. So it's pretty straightforward. So x equals -3, x equals -2, x equals -1, x equals 0, and x equals 2. So that's going to be the form x plus 3. Honestly, for me, the hardest part about these is just remembering to flip the signs. I'm going to assume it's probably going to be the hardest part for you. X minus 2. And then we're just going to put that together. So I've got f of x is equal to sum a, all right, times x plus 3, x plus 2, x plus 1, x times x minus 2. Usually we like to put that x up front, so we would probably like to rewrite this as ax times x plus 3 times x plus 2 times x plus 1 times x minus 2. I think that's just so we don't forget about it. You can, but just it could be, or you might confuse it with a multiplication sign or something. With it, it's just sort of a convention to put that up there. But that's it. That's how you go from graphs to factored forms of both polynomials and rationals.